Record. All right, so simplifying algebraic expressions. We talked a little bit so far about adding, subtracting. We did that the last unit with positive numbers, negative numbers. Same way with our multiplication, division, the rules that go with that. So that's just bringing us into this now, the algebraic expressions. So first off, what's an algebraic term? An algebraic term is each number or number and variable combination in an expression, and they're separated by plus and minus. So I have three examples here. All right, each one of these has a different number of terms. So I want you guys to know first off that a term would be this. 4x is a term. Okay, next one, 3y is a term, and 2 is a term. So each one of those are different. One has an x, one has a y, one doesn't have a variable, but each one of those would be an individual term. Okay, second one. So this guy here has 3 terms. Next one, this one would have 2 terms. And then the last one, how many would the last one have? Anybody? How many terms does this last one have? The one on the right. Good, has 4, correct. All right, 1, 2, 3, 4. All right, now a term is separated by the minus and plus. That separates, this, and this separates. Now, be careful, because for one like this last one, yes, we said it has 4 terms, but this negative sign here, this minus sign would go with the 6. Okay, so we could rewrite that as plus a negative 6g, for instance. Okay. All right. So, what does it mean to be a like term then? So, a like term are terms with the same, what I call variable value. So, for instance, if it has an x and another one has an x, that is the same variable value. An x squared is not the same as an x. Okay? They have to be exactly the same. So I wrote out a group of different terms here. This would all be like terms. They all have just an x. This guy and this guy would be like terms because they're both x squareds. This guy here would be all by itself because there's no variable. All right, so for each one it has what I call the variable value. So if it's a single x, an x squared, a m, a z, whatever it might be, if it's exactly the same variable, those are called like terms. But again, 3x and 4x squareds are not like terms because one's an x squared. And then in this case here, this guy does not have a variable with it, this last one, but it would still be like terms with any other just whole numbers. All right, so why is that important to us? Well, what we want to do is we want to be able to do something called combining like terms. So when you combine like terms, you can add or subtract the like terms together. And what you want to do is add or subtract the coefficients. So the coefficients is the term in front of the variable. So I got 6 problems here. First one, I have 2x plus 5x. All right, like term, 2x plus 5x, I add the coefficients. 2 and 5 is 7, and then the x just tags along. All right, you do not have to add x's together. So a lot of times people try to make the mistake and make that like an x squared or something. That's not the case. They're both terms with x's, so you just need to add 2 and 5 together. Second one, 3a minus 6a, like term and like term. So you have to do the operation to the coefficients. This is a 3, this is a negative 6. 3 and negative 6, or 3 minus 6, is going to be negative 3. So therefore, I have negative 3a. Okay. I'm going to jump ahead to this other one on the left then. 4x minus 5 plus 3x. So this one here, we have multiple terms. Obviously, everything here is not like terms. Okay, I have some x's, then I have a single 5. What I like to do for these ones is I like to go through and underline first. So 4x and 3x, those are like terms. And then this guy's by itself. So I'm going to put a double underline under that. If there was something else, I'd put a triple underline under it. And that just helps me see what I need to combine together. So in this case, I can add the 4x and the 3x together to give me 7x. I combine those like terms. And then the last one, then minus 5, there's nothing else to combine with it, so it just tags along. Okay, and then the last one here, not the last one, the next one here, 2x minus 3x squared plus 4x squared. Again, this guy is not the same as this one. So I put a single line under that one, a double line under this one. This here is an x squared, so these two, 3x squared and 4x squared, would be like terms together. So I'll combine those guys. So when I simplify this, I'm going to have 2x. Negative 3 and positive 4 is going to be a positive 1. So I could write plus 1, or I can just put plus x squared. Because if you remember, any variable with no number in front of it, there would actually be a 1 there. Okay, so now I left 2 of them here on the page. I have 4y plus y and 8a minus 2a plus 4b minus b. I want you to take 30 seconds, and I want you to simplify those two. All right, Clay, 4y plus y. What do you got there, buddy?
5y.
Correct, 5y. Bobby, 8a minus 2a plus 4b minus b. What do you got there?
I had 6a plus 3b.
6a plus 3b. Good. All right, so the first one was pretty straightforward. 4y and y. 4 plus 1 is going to be 5, so that's good. Second one, here and here is like terms. Here and here are like terms. So 8a minus 2a is going to be 6a. And then 4b minus b is going to be 3b. That looks good. All right. Any questions so far? All right. Now, next one. If we are multiplying and dividing like terms, it's very similar. Only thing is, I don't care if they're like terms or not. Okay? They do not have to be like terms to multiply or divide them. All you do is just, again, worry about the coefficients. So here, and the other thing too is with when you multiply or divide, things are attached. All right, we remember if we add or subtracting, yeah, we can move these around, but they don't necessarily have to stay together. When you have multiplication and division, they're really attached together. So here, this first one, 4 times 6x. Yes, one's a whole number. Yes, one has an x in it. That doesn't matter to us. All we want to do is just multiply out front. So 4 times 6 going to be 24. x tags along. All right, I just did the operations to the coefficients again. This is a whole number. Here's my coefficient. Second one, 8m over 2. All I want to do is just divide the numbers. 8 divided by 2 is going to be 4m. All right, last one. I got 6x times 3. You didn't get the answer one last time. What's 6x times 3 going to be? Heidi? 6x times 3 is? What was the number? I only heard x. 18? Is that what we said?
Yeah.
Yep, good. 18x. Good. All right, all we did was just do the operation to the thing out front. Okay. Any questions so far? All right, let's keep going. We got one more thing to do here. Last thing we need to do is something called a distributive property. I'm sure you did this in Algebra 1 because chances are I probably taught you this one. So the distributive property, you have to use this when you cannot combine like terms inside a set of parentheses. We called it the rainbow rule a lot. What you want to do is you want to multiply the term in front of the parentheses by each term on the inside. All right, so here is just the official rule in this box here. Okay, if I have a and then b plus c on the inside, I multiply a to both terms to get ab plus ac. Same thing here. Doesn't matter if it's a plus or minus on the inside, you just carry them along. Just be careful that a here would be times negative c, giving me this negative ac. If my number on the outside has a negative sign in front of it, I also have to multiply that negative sign through. And the one big thing is, too, if you ever get one where it's just a negative sign outside the parentheses, you have to distribute that negative 1 through. All right, so we're going to do a few examples here together. Looks like we got 6 examples, and then I'll finish off this lesson. So, first one here. I cannot combine what's in parentheses. Order of operations says parentheses come before multiplication. I cannot combine, though, a 4x and a 3 because they are not like terms. Since they're not like terms, now I have to multiply the 2 through. So I have 2 times 4x, which would be 8x, 2 times 3, which would be 6, and it's going to be positive, so I have to carry along a plus sign. Now, important thing with this is make sure you cannot combine these. If you can combine them, combine them. If you can't combine them, then you have to distribute. Okay, next one, I have a negative 3 out front. I cannot combine what's inside because I have an a and I have a b, so I need to distribute. Negative 3 times 2a, it's going to be negative 6a. Negative 3 times 3b is going to be negative 9b. Okay. Next two, pretty straightforward. I cannot combine inside, so I have to multiply through my 5. 5 times x is 5x. 5 times negative 3, negative 15. Here is the tricky one, okay? The tricky one is if you have something like this where you have a negative on the outside of the parentheses, but there's no number. Anytime you see that, that means you have a negative 1 out front. Just like if we have a variable with no number in front, there's a 1. Same way here. If we have a negative outside of parentheses, there's actually a 1 there. So I have to distribute that negative 1 through to get negative x minus 2y. A lot of people make a mistake here of getting negative x and not multiplying the 2y by it, so you get an answer of negative x plus 2y. All right, that's not correct. You have to take that negative sign and you have to distribute it through. Okay, and then lastly, last two problems of the day. Sometimes you have to combine what we did up here with combining like terms, combine that with your distribution rule. Okay, so in both of these, I want to combine like terms and simplify as far as possible, but I have to distribute first. So I check in the parentheses, I cannot combine an x and a 3. They're not like terms, so I distribute. So that leaves me 4x plus 2 times x is 2x. 2 times 3 is going to be 6. Now I have the parentheses gone. I can combine like terms. These two are like terms. 6x plus 6. All right, next one. Here I cannot combine what's in my parentheses. I have an a and a b. They don't combine. Multiply here and here. So then I have 6a. Negative 2 times 3a is going to be negative 6a. Negative 2 times b is going to be negative 2b. And then minus 5b. Now I want to combine like terms. Here and here are like terms. Here and here are like terms. 6a minus 6a is going to be 0, so those are gone. And then negative 2b and negative 5b are going to be negative 7b when I combine those. Questions? Okay, last problem of the day. So I'm going to have 5 minus 2 times 3x plus 2 minus 4x. So I want you guys to simplify this guy. Simplify this, do the distribution, combine like terms, and I want you, as soon as you find the answer, I want you to type your answer into the chat box. So I know that each of you did it. Let's see, we got one so far. Clay's locked in. Waiting on 2 more. Alrighty, Bobby, we got an answer?
I'm working on it.
Okay. Okay, I got Heidi's answer. Bobby, I just need your answer yet in the chat box. Okay. All right, let's check it. So,
I did something backwards.
yeah, you picked up an equal sign too.
Yeah, I meant to put plus, not equals.
Okay, if that's the case, you're fine then, I think. All right, so let's check it. We distribute that. So I have 5 minus 6x, and then negative 2 times 2 is going to be negative 4 minus 4x. Combine like terms. Here, 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 and here. 5 minus 4 is going to be 1. And then negative 6x and negative 4x is going to be negative 10x. Now, this answer here of 1 minus 10x, that is exactly the same as 10x plus 1. Either one of those is fine. Neither one of those is wrong at all. All right. Any questions, guys?